This presentation is focused on climate change. The overall goal of this is for you to be able to define and describe climate change, understand what risks, especially environmental health risks, are associated with climate change, health impacts, and then to think about the terms mitigation, adaptation, and evidence-based public health. In a 2014 report by the EPA called Climate Change Indicators in the United States, they referred to climate change as any substantial change in measures of climate, temperature, precipitation that lasts for an extended period. And this may be naturally caused or based on human activities. For many years, we often use the term global warming as climate change, but we've come to understand that they're not the same thing. Global warming refers to an average increase in temperature of the atmosphere near the Earth's surface. And global warming is just one aspect of climate change, although a very important one. I have two links here below that show the original PDF that I took this image from, and then a similar report, because that first report's not available, and the similar report was updated in 2016. I have both of these throughout the presentation, and this is the main source of information that I'm using for this presentation. How does global warming work? What do we see? The main thing that we see is that the sun's radiation is typically reflected by the Earth and the atmosphere. When the radiation is absorbed, it warms the Earth's surface. This absorbed radiation that gets re-emitted can be higher because of the type of gases that are in our atmosphere. So when we have more gases that keep the heat and energy from the sun in the Earth's atmosphere, it results in warming. These gases that are associated with this are typically called greenhouse gases, and they include carbon dioxide, methane, nitrous oxide, fluorinated gases like chlorofluorocarbons, and water vapor. Water vapor is the most abundant greenhouse gas in the atmosphere. Carbon dioxide is the one that we're most concerned about controlling and that we believe we have the most ability to control. It's mostly emitted through fossil fuel burning. And I'll show you a variety of figures that document this. From the original EPA report published in 2014, the key findings were that globally, as well as in the US, greenhouse gas emissions are fluctuating, but energy generation is the largest source in the US, followed by transportation. So using electricity, any way that we generate electricity, and then how we burn fuels for transportation. Global temperatures are increasing, and in 2014, the top 10 warmest years on record have occurred since almost the end of the 20th century, or 1998. Other things, in addition to heating the Earth's atmosphere, are happening. Besides heat waves, we're seeing drought, we're seeing increased heavy precipitation, and changes in storm frequency and intensity. This figure, which is very similar between the two reports, shows what the main emissions are for greenhouse gases. And you can see that electricity generation and transportation are the main emission sources for greenhouse gases in the US. Over 2 decades, we see, again, millions of tons of greenhouse gases emitted primarily through energy. This is globally, not just in the US, but then also through agriculture and international transportation, which has grown, although it's still a fairly small piece. The main greenhouse gas in the United States that's being emitted is carbon dioxide. Carbon dioxide is produced, again, through fossil fuel burning but there are many sources for how carbon dioxide is produced. Methane is the second largest one, and methane can be produced in a variety of ways. Cattle are well known for producing methane. As we learned from our knowledge about solid waste, sometimes landfills produce methane, although that's a pretty small amount. And then we see nitrous oxides and the chlorofluorocarbons. Regionally, high-income countries contribute the largest amount to carbon dioxide emissions globally. So you can see Europe, parts of Asia, and the United States contribute the largest amounts, whereas other parts of North America, South America, Africa, and the Middle East, and Australia and Oceania contribute relatively small amounts. And it's one of the reasons why globally we've come together to do carbon emission reductions, although recently the United States left those agreements. Temperature trends globally also indicate major increases in temperatures worldwide. And this is the Earth's surface, both land and ocean. 2015 was the warmest year on record. 2006 to 2015 was the warmest decade on record. And average temperatures are rising at about a tenth to a 20th of a degree Fahrenheit per decade since 1901. How does this appear in the United States? The graph that I'm showing you now shows rate of temperature change in the United States over the last 114 years. You can see that average temperature has risen and 48 states have been warmed over the decade. Some parts of the U.S. are experiencing more warming than others. In particular, the North and the West, as well as Alaska, have seen the greatest increases, and the Southeast has experienced the least change. However, not all of these regional differences are separate and distinct. In addition to overall average temperature increase, we see another important factor, which is high-low temperatures. And what that means is that the lowest temperature of the evening does not go down as low as it should. And in times of heat stress or extreme heat events, this can be deadly for populations because there's no reprieve or rest from the heat. Overwhelmingly, we see that the lower 48 states, summer daily low temperatures are well above normal. And we see both high daily temperatures and high low temperatures. And this is really important when we talk about summer months and how people deal with the heat. We also see major differences in precipitation, where we see broader increases in total volume and variability across. So when we used to see periods of rainfall in certain times of the year in certain regions, that has shifted, and we see greater increase in temperature, precipitation throughout the United States. Larger amounts, often perhaps less frequently. Some regions are experiencing more rate of increased precipitation than others, and some are experiencing some less change. But overwhelmingly, you see almost everyone is getting an increase in the rate of precipitation. In certain settings, though, we also see drought. Part of the reason that we saw fires in California this last year was because California had been under a major drought for many years, and the land is very dry. It's very easy for a fire to start. It's very difficult to put it out. With the recent rains that California has experienced, which again have caused other catastrophic things like mudslides, people have had to evacuate from their homes. California is, for the first time in maybe 5 or 7 years, no longer in a drought. But we do see increasing drought. In 2008, 2010, Atlanta wasn't experiencing a drought. And droughts can have major impact on a lot of factors. We also see high annual precipitation increases, and especially in certain time periods. Last year, I believe that Georgia experienced more or as much rain, at least Atlanta, as Seattle, which is unheard of. And this is another factor associated with shifts in climate. And we see global sea temperatures increase, which has tremendous impacts on lots of different things, as well as sea level rise. So when temperatures warm, ice melts, and we see sea level rise, and it has huge impacts. If you've been following the news at all, there's been a terrible cyclone that hit southern Africa. It landed in the city of Beira, Mozambique, a city of about 500,000 people, pretty much at sea level. And the estimate suggests that at least right now, hundreds have died, maybe thousands. And the entire city, 90% of it has been destroyed. It's a tremendous disaster that happened. And again, it's a big example of how climate change is impacting us globally. As I mentioned, we're seeing dramatic melting of ice. You see pictures of this all the time. This is just one example, but it's happening all over. There's strong evidence that ice is melting and that the older ice is decreasing too, and it's important. So as I just mentioned, and as we were seeing not only in places like Mozambique, but even in the United States, where we're seeing the Midwest floods that are destroying farms, that are destroying towns, one of the effects or possible effects of climate change is an increase in natural disasters. This information comes from an epidemiologic center focused on epidemiology of natural disasters. And when we think about a disaster, we think about three components. The first is disruption of normal activity. The second is human suffering and property damage. And it also is requiring outside assistance. We saw this recently in the United States in places like Houston, where there was such dramatic flooding, people had to be rescued. And of course, in 2005 with Katrina. Types of disasters, we can think about natural disasters, earthquakes, volcanoes, storms, floods, climatologic disasters like heat waves and droughts, and also biologic disasters like epidemics that kill off large amounts of the population. There can also be technological disasters, industrial releases, accidents, building collapse, and transportation disasters. And of course, ones that we don't think about that often as much as we used to, man-made disasters like bioterrorism or terrorism. These have shifted now. When we think about this, it's often mass casualties because of shooting. While this figure is a little bit old, it examines the trends in natural disasters from 1988 to 2007, so a 20-year period. And you see that hydrological disasters are greatly increasing over this 20-year period in terms of total numbers of disasters. And this is a huge impact on everyone. When we think about the short-term effects of major disasters, you think about the different types of disasters we might be discussing: earthquakes, floods, high winds, slow onset floods, high tidal or flash floods, volcanoes. We see different levels of death, severe injuries. Across all of them, we see an increased risk of infectious disease transmission. And for almost all, we see damage to healthcare facilities, likely damage to water systems, and common for many are, especially the hydrologic ones, are food shortage and often major population movements. forced migration out of regions because the area is no longer inhabitable. We start to think about a profile of what happens during a disaster. At the onset, there's large-scale evacuation that happens. For environmental health, we think about the need to supply emergency water, sanitation, and vector control. If you think about what's happening in Mozambique and Beira right now, people are being rescued from treetops. They have no food, they have no water, and trying to get to the population, they're really in this emergency. We need to get them food, water, and a place to shelter. Disease surveillance and control starts to happen days following the disaster. We start to see an increase in need for primary health care, and we start to see a need to start to distribute food. So this is all in the first few days of a disaster. For 25 years, 30 years, the center tracked major disasters, and you can see while hydrologic disasters are frequent in nature, they often don't cause the type of drastic death that you see from drought. And drought causes so many deaths because it puts entire regions at risk of food shortage, food supply shortage, malnutrition, and eventually famine. In the mid-80s, there was a major drought happening in Ethiopia and Sudan. And as a result, a number of artists in the United States came together and did a song called We Are the World. And there's a link to it here if that link still works, to raise money to support the people in that region. Drought has one of the biggest impacts because it impacts so many people. What are some of the health effects of natural disasters which we think will increase under the current climate change scenarios? We see increased opportunities for disease transmission, population displacement, exposure to the elements, food shortages, malnutrition, water and sanitation breaks down. We see increased risks for diarrheal disease. Of course, mental health concerns, both acute and long-term due to lengthy rehabilitation process, and major damage to health infrastructure like hospitals and health centers. As the paper will show you, and as we should start to think about, I think climate change is a very important example of environmental injustice on a global scale. There is an inextricable link between poverty and disaster, both in high-income countries and for low-income countries. And the reason that poor people are so much more vulnerable for disasters is that they are harmed both physically, socially, environmentally, and economically. You can see that overwhelmingly the number of victims from natural disasters is much higher in developing low-income, middle-income countries than it is in high-income countries. What are some other health risks that we're concerned about when we think about climate change, aside from natural disasters, of which both the United States and other countries are currently experiencing? We can think about extreme heat events, and this, aside from the sort of dramatic effect of floods, extreme heat events kills more people annually than any other climate condition. There's decreased air quality. We see challenges to water quality and diarrheal diseases, and we see changes in where vector-borne diseases are being transmitted. So tick-borne disease, West Nile virus. In the United States, those used to be isolated to very specific regions. As we start to see changes in temperature, it allows the vectors to go to different regions, and we see a lot more of that distributed geographically. And we can also see risks to our built environment. In the mid-90s, there was a heat wave in Chicago that estimated to kill hundreds of people in a very short time period. One of the challenges with Chicago is that many people live in high-rise apartments, and they often don't have air conditioning. And elderly people, people that are isolated, people that can't leave their homes very easily or afraid to go, or even afraid to use their resources, they don't want to turn on the air conditioner, are at risk. So many people died during this time period that the morgues were full. They had to bring in refrigeration trucks to store bodies. There's a couple of videos here for you if you would like to use those and think about watching the videos. It was a very, very serious event in the United States. We go back to the EPA report, and I'll just remind you some of the things we were just discussing in the previous slide. We see heating and cooling increase. We spend more of our resources on heating our homes and cooling our homes. We spend more money on that. That and then uses more energy and puts out more heat into the air. We see an increase in heat-related deaths. We see, as I mentioned, tick-borne disease like Lyme disease gets distributed in regions that it didn't used to be. Shifts in the growing season. So because of changes in precipitation, our agricultural practices will shift. We can't grow certain things in certain regions anymore. And then we see changes in the pollen season. And of course, many people in Atlanta will start to experience this now. We see shifts in the length of the time. And we also understand that because plants use CO2, they may be growing more rapidly and producing more pollen. This again is looking at heat-related deaths and in the District of Columbia, and you can see if you just use underlying cause of death being heat, but if you add on that people that have pre-existing conditions are much more susceptible to heat-related illnesses, then we see a much greater increase in the number of people dying as a result of these events. So when we think about climate change, we think about two things. We think about mitigation, which is how do we stop heating or contributing to climate change? How do we stabilize or reduce greenhouse gas production? And we do this through both policies like national, international accords and technologies. Using cars that burn less fossil fuel is one example. Using cars that burn ethanol is one example. We may have to consider how these strategies impact everyone though, because just like climate change, our mitigation strategies can exert more pressure on poor populations, on the vulnerable people. I'll give you just one example. When we increase taxes on fuel, this disproportionately affects poor populations because poor households spend more of their money on fuel than wealthy households. And so when we increase taxes, that tax impacts the poor populations more. Lots of mitigation strategies are present. We can think about taxing fuel as a policy. We can think about shifting to biofuels. So there was a substantial effort to increase ethanol-based fuels. We can talk about how we distribute electric power, if we could shift to other forms of transportation, but we have to consider how all of these impact everyone involved. So the main goal of mitigation is to stabilize or reduce gas production so we can slow the impacts of climate change. And the current thinking is that we have about 12 years to do this, or we will no longer be able to reduce the impacts of climate change. the current president and his policy advisors at the EPA say, we're not worried about climate change because that's 50 to 75 years out. But the reality is we have to make choices today that will impact the climate in 50 to 75 years. We separately have to build adaptation strategies. These include efforts to reduce the public health impact of climate change. This may focus on public health preparedness, which works for many reasons. If we can be more prepared for natural disasters, for emergencies, we're strengthening our public health systems while being prepared to reduce the effects of climate change. And we can build on these prevention strategies with our current prevention efforts. However, we have to consider everyone. We can't put together strategies and solutions that only protect those that aren't vulnerable. When we think about why we should be thinking about climate change adaptation, we can get benefits to doing these mitigation and adaptation that are cost effective and politically feasible. Although nowadays, that's not always the case. But all of these approaches need to consider the consequences. And I'll just remind you of the biofuel example as one consequence. So, mitigation measure was, let's produce more fuel from corn and ethanol. And what ended up happening was that diverting feed and fuel to biofuel production has increased food prices worldwide. So here we are saying, here's a strategy to reduce or stabilize greenhouse gas emission by switching the fuels that we rely on. But what it ended up doing was having an unintended impact on populations that we perhaps weren't considering. Lastly, I just want to ask you guys to think about and consider what this term means, evidence-based public health. This is the development, implementation, and evaluation of programs and policies through the principles of scientific reasoning. It's a process by which evidence is assembled, evaluated, and integrated into public health decision making. We need scientific research. We need practice to understand what are the best ways to impact public health. And this is a field that we should all be trying to understand better. We should be thinking about examples. We should be evaluating programs. We should be looking at successes and learning from failures and constantly evolving our public health practice to make things better. So lastly, I want to talk about this article that I want you to read. I've discussed many of the components of it in this presentation, but the title of the article is Climate Change, Human Rights, and Social Justice. The authors argue that global climate crisis may be the defining moral issue of the 21st century, that climate change affects low-income countries and poor people in high-income countries, and that even within that, there are disparities among countries, among different vulnerable populations, and the environmental and health consequences that impact these groups. So I ask you to read this and think about it, and think about it in the context of everything we've discussed this semester. So from food to water to air to environmental justice to how global health is linked. And I'll leave you with these last two slides. The first one is a cartogram. And if you've never gone to this website called World Mapper, please do. This looks at the shape of the country and it distorts it by taking the size of the country and making it bigger or smaller depending on its use. And what you see here is that carbon dioxide emissions are greatest in places like China and the United States and Europe. And you see very little carbon dioxide emissions from most of Africa. This is a good example of how those wealthiest economies contribute the most to climate change. Here is a map of flood deaths between 2000 and 2017. And you see overwhelmingly Asia, Bangladesh, and places in sub-Saharan Africa have the biggest impact. And we see also some in South America, in Central America, and the Caribbean. Europe, the United States, even China has very little impact from floods because of geographic distribution of water sources, of infrastructure, of resources to combat during floods, of ability to respond. But it shows you that how unequally distributed the impacts of climate change will be.